so next in this session, we are going to talk about how to solve by elimination. Now, this method will work with any system no matter what. And just like before, we're going to write our answers as ordered pairs, and if we have fractions, we are just going to leave things as fractions. Okay. Now, when we are solving by elimination, our goal is to eliminate a variable, and we are going to do that by adding the equations together. So when we add the equations together, they have to be in the same formatting. So usually we want it as x, y equal to a number. But if we have things flipped around, so let's say I had y plus x equals a number, as long as my second equation matches that same formatting, that's okay. So the formatting has to be the same in each equation before we are allowed to add them together. Okay. And then when we do add them, we might need to multiply one or both equations by a number, and it would be different numbers if we're multiplying both equations. So that way when we do add the equations together, either the x values or the y values add to be 0. Okay. So looking at number 9, the formatting doesn't match because here I have x, y equals a number, and this one I have y, x equals a number. So I'm going to need to do some flipping around. So I'm going to make the top equation match the formatting of this second one. So I'm going to put this negative 7y first, so negative 7y, and then plus x equals 11. Okay, so now I'm ignoring this top equation. Okay, so now I need to decide which variable I want to get rid of. Now they don't add nicely, so like the y's don't add to be 0 yet, and these don't add to be 0. So I'm going to have to multiply either one or both equations by something. So let's say I chose to get rid of the y's. That means that I would have to multiply this top equation by 7, and then the bottom equation by 4, and that would create opposites. So when I do add them, they cancel out. Okay. Or if I chose to get rid of x, this one, since I'm looking at this, I would multiply this by a 1, which isn't going to change anything. And then I would multiply this by 5, and I would have to make one of those numbers negative, so that way when I do add them, they cancel out. So I'm going to choose to eliminate the x value, and I'm going to do that by multiplying this equation by negative 5. Okay. So this will be 35y minus 5x equals negative 55. And then my second equation is just going to stay the same because I would technically multiply it by the 1. That's with the x. So I'm just going to rewrite it. So 4y plus 5x equals negative 23. Okay. So when I add, this will give me 39y. That adds to 0. And then that equals negative 78. And now I just solve for the variable that I have left. So I would divide both sides by 39. So that means y equals negative 2. Now at this point, if we wanted to, we could go back and do the elimination process for y, which would take a little bit more time. But now that we have this number, we can go back and just pick one of these equations, and we're going to substitute this number into the y spot and then solve for x. So I'm just going to use this top equation. So I will have x minus 7 times negative 2 equals 11. So that will be 14. And then I would subtract the 14 over to get the x by itself. So that means x equals negative 3. So my coordinate would be negative 3, negative 2 for this one. All right, so going to 10, again, the first thing that we want to do if it's not formatted the same is to make the formatting the same. So we have a couple options. I can subtract the 8y over so that I have xy equals a number. Or on this one, I could subtract the 9y over so that I have x equals y and then a number. So it doesn't matter which way you do it. I'm going to choose to put x and y on the same side because I just prefer that better. So I'm going to subtract this 8y over. So this will be negative 7x minus 8y equals 9. so again, I'm kind of ignoring this top one, and I'm looking at these equations. So I have to decide if I want to get rid of the x or the y. And again, it doesn't matter what you choose. For this one, as I'm looking at it, there's really nothing that I can take times 4 to get 7 or times 8 to get 9. So that tells me that I'm going to have to multiply both equations by a number this time to do the elimination. So I'm going to choose to get rid of x again, just because these are smaller numbers, but we could also get rid of the y, so it doesn't really matter. So if I do that, I'm just going to take the top equation times 7, and then this bottom equation times 4. And then because these have the same sign here, I need to make one of these negative, and it doesn't matter which one. So I'm just going to make the 7 negative. All right, so now we are distributing that negative 7 in. So that will give me a positive, change colors, positive 28x. And then that will be a negative 63y. And 22 times 7, 154. And then now I distribute the 4 in. So this will be a negative 28x minus 32y equals 36. So we are going to add those together. The x's add to be 0, so that cancels. This is going to give me a negative 95y. And let's see, that'll be 0, 6, 1. So 160. And then to finish, we are just going to, oh wait, nope, that's not right. 90. So now we need to divide by 95 to both sides, negative 95. So 190 divided by negative 95 is going to give me negative 2. And now that I have that number, I'm just going back up to one of my originals or the one that I rearranged, and we're going to substitute that in. So I'm just, again, going to choose that top one. So negative 7x equals 8 times negative 2 plus 9. So this will be negative 7x equals negative 16 plus 9. Negative 7x equals negative 7. And then if we divide both sides by negative 7, that will be a positive 1. So 1, negative 2 is my point of intersection. All right, so if we keep going, so again, on 11, formatting doesn't match. So the first thing I'm going to do is I'm going to add the 6 over and then add the 8y over. So I'm looking at 2x plus 8y equals 6. Okay. Now there's a couple different things that we can do. Again, if we're eliminating, I can choose to get rid of my x and multiply everything by 5 and then by 2. Or I can look here and get rid of. If you also notice, in this top equation, they're all divisible by 5. So if we wanted to make the number smaller, we could do that. Same, these are all divisible by 2, so I could divide everything by 2 to make the number smaller. You don't have to do that, but it is an option. So what I'm going to do is I'm going to choose to eliminate the x, and I'm going to do that by taking this equation times 2, and then this one times 5. And then because these are the same sign, I have to make one of them negative, so I'm just going to make the top one negative. And then distribute, so that will give me negative 10x minus 40y equals negative 30. Distribute the 5, so 10x plus 40y equals 30. So as I'm looking at that, that adds to 0. Negative 40 plus 40 adds to 0. So I'm left with 0 on this side. Negative 30 plus 30 is also 0. So just like when we were at substitution, if all of our variables cancel out, whatever numbers we're left with, we're just deciding if it's a true or a false statement. So this is a true statement. So my answer is going to be infinitely many. and I have to give the equation with my answer. So if I go back up here, I'm just going to pick this top equation to solve for the y. So kind of off to the side here, if I have 2x minus 6 equals negative 8y, to get the y alone, I'm going to divide everything by negative 8, and then I'm going to simplify. So that would simplify to be a negative 1/4 x. That's going to be a positive, both divisible by 2, so 3/4 equals y. So the equation is negative 1/4 x plus 3/4. So this is my answer. All right, so again, looking at this one, I'm going to change my formatting. So I'm just going to switch the x and y around. So this will be negative 2x plus 4y equals 6. And I'm going to get rid of the x's just because the numbers are smaller. So I'm going to take everything times 2 and then times 3. And then since they're the same sign, again, I have to make one of my numbers negative. So if I distribute negative 2 in, that will be 6x minus 12y equals negative 16. And now distributing the 3, so negative 6x plus 12y equals 18. Adding them together, so x's add to 0 and the y's add to 0, so I'm left with 0 on this side. And then negative 16 plus 18 is 2. So all the variables canceled out and I'm left with numbers. That is a false statement because 0 cannot be equal to 2. So my answer to this one is no solution. Now, as you guys start doing your homework for this section, you can pick which method between the substitution and the elimination to use. You can do one every time. You can go back and forth between them. I will leave that up to you as you start practicing these problems.